In this video, we will be learning about chemical bonding. The learning objective for this video is to describe how chemical bonds form. Primarily, we will be talking about ionic bonds and covalent bonds. So, chemical compounds are held together through chemical bonds. And so the atoms are connected through these chemical bonds that define what the compound is. And so the chemical bonds are classified as either ionic or covalent. And really there's a third category called metallic, which we will not be talking about, unfortunately. So we will be talking about ionic and covalent bonds right now. And so I have some examples of covalent bonds here between nonmetal atoms, such as carbon atoms in diamond and carbon atoms in graphite. And this is a pure element of N2, and this is CO2. And these molecules are also held together through covalent bonds. Over here, I have an example of sodium chloride and ACl, which is held together through ionic bonds. So in covalent bonding, the atoms are sharing electrons. They may share 2, 4, or 6 electrons between them. And we'll get more into why they're sharing 2, 4, or 6 electrons in the next chapter and later on when we cover how to draw molecules, such as writing Lewis dot structures in a later unit. But for now, you need to know that covalent bonds occur between 2 or more nonmetal atoms. And so this is a pure element. This is O2, and that's held together by these oxygen atoms sharing 4 electrons. And so that's known as a double bond, and so that's oxygen with 2 lines in between it, if you're going to draw its structure out. And here, these atoms are sharing the electrons. Some of these electrons are represented by X's to kind of show which atom was contributing which electron. The X's are from the hydrogens, but these electrons here are shared. It's like a Venn diagram where this middle region is what's shared in between the two things. So if you ever filled out a Venn diagram, that overlapping region has things in common between both groups. And so that little overlap between the two atoms are the electrons that are being shared. Ionic bonds do not involve sharing at all. Ionic bonds involve a transfer of electrons from a metal to a nonmetal. And then I do have a disclaimer here because we'll be talking about polyatomic ions very soon, and not all polyatomic ions have a metal in them. But if a metal gives up its electrons, then it's going to form a cation. And when it gives a nonmetal an electron, that nonmetal becomes an anion. And then you have opposite charges. You have a positively charged cation and you have a negatively charged anion. And then those two are going to be very attracted to one another through an ionic bond. So opposite charges attract. So they're attracted like magnets. And so here's a diagram to kind of show you that. So this is sodium metal, and as you can see, it looks like a metal. And this is chlorine gas, and when chlorine's a gas, it's one of our diatomic elements. And so you can see these little 2 atom molecules in here, and that's like single atoms of sodium smushed together. That's an atomic solid. And then one of these sodium atoms has 11 electrons, and it's going to give one of those electrons to chlorine. Chlorine started off at 17, so once sodium gives out an electron, it's going to be 18 electrons. And sodium is going to go down to 10 electrons. Since sodium has lost an electron, now it has excess protons, 1 excess proton, and chlorine has 1 excess electron. So that's my cation, and this is my anion. And now these are oppositely charged, and that means they're going to stick together like magnets. Those opposite charges really attract, and then you form an ionic compound known as sodium chloride, which is table salt. So go into your kitchen and find your table salt and say, aha, I would like to sprinkle some sodium chloride on my food tonight. And so some elements have predictable ion charges for when they form ionic compounds. Everything in group 1 would like to be +1. So everything here likes to be +1. Everything in group 2 likes to be +2. And so you can see the pattern with the group numbers here. On the other side of the periodic table, we have common ion charges of -1, -2, and 3-. And so you can see those common ion charges. And that has to do with how many electrons they need to get to the closest noble gas. And so you can see that 1 + 7 adds up to 8, 6 and 2 adds up to 8, and 3 and 5 add up to 8. And so they're all trying to get to this noble gas area. Then there's this little region, this cool little triangle here. Doesn't really have an official name. I'm just going to call it the cool triangle in the middle of the transition metals going into the main group. But it starts at silver and goes up through aluminum and down through indium. So if you want to locate that on your periodic table so that you can find it, silver likes to be +1, and so there's only 1 element here. There are 2 elements here that like to be 2+. And then there's 3 elements that like to be 3+. So 1 element is 1+, 2 elements are 2+, and 3 elements are 3+. And so how many elements are in that part of the triangle will help you remember which charge it is. You should recognize and memorize these common ion charges for when we're forming ionic compounds in the upcoming videos.